In the previous class, I started talking about the inductor and the capacitor. And I told you that for the inductor or the capacitor or the resistor, I have 4 different equations. The equation for the voltage, the equation for the current, the equation for the power, and the equation for the energy. And I have to know all of these 4 equations. In case of the resistor, we said that V is equal to I times R. In case of the inductor, we said that V is equal to L di by dt. In case of the capacitor, we said V is equal to 1 over C integral of I dt plus the initial voltage. For the current equation, in case of the resistor, we said I is equal to V over R. For the inductor, we said I is equal to 1 over L integral of V dt plus the initial current. For the capacitor, we said I is equal to C dV by dt. For the power equation for all of them, we said P is equal to V times I. For the energy equation for all of them, we said the energy is equal to integral of P dt. In the previous class, we solved some problems related to the inductor, but we didn't solve any problem related to the capacitor. Let us solve today problem related to the capacitor. Imagine we have this guy. This is IC of t, and this guy is VC. And this is the capacitor C, and C is equal to 0.2 microfarad, and VC of 0 is equal to 0. He told me that if IC of t is defined by this function, 0 for t less than 0, and 500t for t is in between 0 and 20 microseconds, and 0.2 minus 5000 t in case of t in between 20 microsecond and 40 microsecond, and 0 for t greater than 40 microsecond. Now what is needed is the voltage VC of t. He asked you to calculate VC of t, calculate the power P of t, calculate W of t, which is the energy, and he asked you, can you please sketch? And for sketching, guys, I'm not looking for the actual graph. I'm looking for a sketch. You know, you can choose 3 different points and substitute and draw the curve based on that. So he asked you to calculate calculate V, calculate P, calculate the energy. If you try to draw actually he gave me I like that. It's given. He said this is 40 microsecond, and this guy is 20, and this guy is 0, and this guy is IC of t. This is given actually, and this guy is 0.1. So he would like to find VC of t for that problem. So for finding VC of t, the equation for VC of t is equal to 1 over C integral of I of t dt plus the initial voltage, or V of 0. It is VC of 0, but for simplicity, I wrote it V of 0. So he would like you to calculate VC of t at any time t. You told me that VC of 0 is equal to 0, so I will put VC of 0 is equal to 0. But he asked me to find the integral of I dt. The problem here is I is defined by different definitions. So I have to divide my problem into different periods. The first period, if t is less than 0, actually I is approximately equal to, if t is less than 0, I should be, based on that equation, he told me that v of 0 is equal to 0. So this guy will be 0 and this guy will be 0. The v will be 0 before 0. No need to write that. I will talk about the period from t greater than 0 and less than 20 microseconds. By the way, less than or equal, it doesn't matter because this is continuous function. There is no discontinuity. I mean, I don't have different values at the same point. You studied in mathematics points of discontinuity, right? Sometimes the function is defined by two different definitions at a specific point. But here, if you try to use this line for finding I at 20, it will give you the same value if you try to use this line. So it doesn't matter if you wrote equal or less. Okay. Now he would like to find VC of t. So VC of t is equal to 1 over C. What is C? Actually, he gave me 0.2 microfarad and the current is 500 T. So I will write 1 over C, which is 0.2 multiplied by 10 to the power -6 integral of, is it 500 or 5,000? I think it is 5,000. By mistake, I wrote it 500. It's 5,000. So this guy is 5,000 T dt plus the initial voltage VC of 0, which is 0 in our case. This integral from 0 up to t. Some of you are asking me for this integral, should I put from 0 up to 20 or from 0 to t? The answer is from 0 to t. Why? Because you would like to find the equation. But if you try to substitute from 0 to 20, you are not finding the equation, you are finding value, which is not right. I have equation for v. That's why I'm substituting from 0 up to t. If you would like to find I at any time t between 0 and 20, you can substitute t by any value that you want. But if you found from 0 to a specific value, you are finding the current at a certain point. You see what I'm talking about, guys? So if you try to find the integral of this guy, will be 5,000 t squared over 2. And this guy is divided by this number. So at the end, VC of t should be equal to, if you try to calculate it, 12.5 multiplied by 10 to the power 9 t squared volts. This is the voltage for the periods from 0 up to 20 microseconds. This equation is giving you straight line or curve. Yes, it's curve. So I'm expecting that if I would like to draw my V, it will be something like that. It will be something like that. And if you try to substitute here by t is equal to 20, this guy will be equal to 5. This is VC of t. Now, I would like to find VC of t for the next period, which is from 20 up to 40. From 20 up to 40. But before leaving that, he asked you also to calculate the power and calculate the energy. So it is a good idea to calculate the power and the energy at the same time, because you are talking about that period, right? So if you try to find VC of 20, microsecond, like what I told you, it is equal to 5 volt. Now, let me talk about the power and the energy. If you try to calculate the power P of t, it is equal to Vc of t multiplied by I of t. Actually, V is equal to 12.5 times 10 to the power 9 multiplied by, no need to write multiplied, I can write it t. T squared, this guy multiplied by 5,000 t. And this is watts. Then this guy will be equal to a specific number multiplied by t to the power 3. So this guy will be equal to, can anyone multiply these two numbers? 12.5 times 10 to the power 9 times 5,000. I think I have here. I think it is 62. I think it is 62.5 times 10 to the power 12. Is it right? T to the power 3. And my notes, I wrote it T to the power 2. So please correct it. It is T to the power 3. Then you will try to find the work or the energy, which is equal to integral of P dt from 0 up to T. And actually, T here is equal to 20 because I would like to find the energy during that period. So I can find the energy at that time as a value. Or if you would like to find it as a function of T, that's okay. So integral from 0 up to T or up to the value as you like. So if you try to substitute by this guy as a function of T, it is equal to integral of this. So it will be this number divided by 3. Sorry, this number T to the power 4 divided by 4. Yes. So if you try to calculate this guy, it will be equal to 15.625 times 10 to the power 12 T to the power 4. This is in case of you are talking about the power and the energy in that period, which is from 0 to 20. Then if you would like to draw these two curves, this is T. And if you would like to draw the energy as well, you will find that this guy is representing the energy. This is 20 and this is 20. This guy is the energy W of T. And this guy is representing the power P of T. You will take 2 points. Pot T is equal to 0, and here pot T is equal to 0. So both of them you are starting from 0. And this is curve at T is equal to 20 microseconds. At T is equal to 20 microseconds, substitute to find W and P. You will find that this curve, so it looks like something like that. And this guy looks also something like that. So this is 5 if you try to substitute, and this guy will be equal to 50, and this is in milliwatts. And this is in millijoule. Now, the next step is to try to find any question before leaving? Yes. Yes. This is T to the power 4 and this is T to the power 3. So you will substitute by T is equal to 20 as T is increased, the value of the power or the energy is increased. I know what you are talking about. If you would like to draw actual one, you have to substitute by another point and then connect these 3 points. But this is just a sketch. Now, what is the next step? The next step is you will try to use the next period, which is this one. But for this period, what is VC of 0? What is VC of 0 for this guy? Excuse me? Yes, VC of 0 is equal to 5. Because 0 time here is 20. It is not t is equal to 0. So it is Vc of t for the starting time, which is 20. Yes.
So when you're plugging that into the equation, you have to
for the integral here, I will put from 20 up to t. And for this guy, I will put 5 because the initial time at that time is 20. It's 20 microsecond.
So would I put like 20 times 10 to the negative 6? Or would I put
No, you will put here, you will substitute here by t is equal to 20 microsecond and calculate the corresponding v, which is 5. And then you will write that equation. So for the period from t, let me change the color, greater than 20 up to 40 microsecond, I can say Vc of t is equal to 1 over c multiplied by integral from 20 microsecond up to t. For what? For the new function, which is this function, which is equal to 0.2 minus 5,000 t dt plus the initial voltage at t is equal to 20 microsecond. In our case, this guy, I think it is equal to 5. You got it?
Yeah, but so up there it's like 12 times 12.5 times 10 to the 9.
Multiplied by t squared. T here is t here, t for this guy, it is equal to this time, 20 microsecond. Yes. Then you will try to calculate this guy. The integral of this, if you try to find it, integral of 0.2 will be 0.2. Integral of negative 5,000 t will be negative 5,000 t squared divided by 2, right? So multiplied by this number, at the end, you will get 10 to the power 6 multiplied by t negative 12.5 times 10 to the power 9 t squared. And here in the notes, I found negative 10. Then you will try to find P of t, which is equal to V of t times I of t again. And you will try to find W of t, which is equal to integral of P dt. So if you try to calculate the value of P, actually P will be equal to 2.5 times 10 to the power 12 t cubed minus 7.5 times 10 to the power 9 t squared plus 2.5 times 10 to the power 5 t minus 2. Please check that. And for the power, you will get 15.625 times 10 to the power 12 t to the power 4 minus 2.5 times 10 to the power 9 t cubed plus 0.125 times 10 to the power 6 t squared minus 2 times 10 to the power negative 15 t. This is in case of t in between 20 and 40. And then after that, for t greater than 40, what is the value of V? Actually, for t greater than or equal to 40 microsecond, I will substitute here in this equation. If you substitute it in this equation for t is equal to 40 microsecond, you will find that 40 times 10 to the power 6 minus 12.5 times 10 to the power 9 times 40 microsecond square minus 10. So it will give you a number, right? This is the value of t for t is equal to 40 microsecond. What about for the current? The current actually will be equal to, where is the current here? The current will be actually equal to 0. So what about the power? The power will be equal to 0. What about the energy? At that time, the energy will be equal to the integral of the power, but don't forget, we have voltage, which was equal to 10, and the energy is equal to half CV squared, right? So at 40 microsecond, I have a specific energy, which is half CV squared, which is equal to 10 microjoule. So at 40, I have voltage, I have energy, but I don't have power. I don't have current, but I have values for the voltage and I have values for the. Yes, you have a question.
Your V0, how did it go from -5 to then -10?
Excuse me, which part you are talking about?
Go down a little bit.
Yes.
So right there, between when you solve for V, you have 10 to the power 6t minus 12.5, and at the end you get -10.
Yes. So substitute in this guy. The integral of this 0.2 times t minus 5,000 t squared over 2, right? Then substitute from 20 to t plus 5. This is the last equation that I got. If you try to substitute in this guy, you will find 0.2. So if you try to substitute in this guy, it will give you 0.2t. And you will substitute by t from 20 up to t. So 0.2 multiplied by open two brackets, t minus 20. And for this side, I have 5,000 t squared over 2. So 5,000 over 2 multiplied by open brackets, t squared minus 20 over all squared. T squared minus 20 over all squared. Not t squared, t minus 20 over all squared. And then simplify that after adding 5 to it, it will give you that equation. Got it? Then try to draw that. Actually, if you would like to draw this curve, probably this curve will be something like that. Probably this curve will be something like that. I'm asking you to sketch, if you would like to be sure what your curve look like, you have to choose one point here, and you have to choose one point here, and then connect between this and this and this, you will get a specific curve. But I didn't ask you to draw the exact, I'm asking you to give me the sketch. So any curve that you will give me will be acceptable. Okay, guys? Now, if you try to continue drawing that, you will realize that this guy for the power will be like that at 40, and this guy will be like that, and this guy will continue like that. Stop. Okay, what I would like to show you here, if you try to look to these curves, guys, and this is what I mentioned at the end, if you try to look to these curves, at t is equal to 40, based on these curves, at t is equal to 40, the current is equal to, yes, but the voltage is equal to a specific value, right? What about the power? It is 0. Why it is 0? Because P is equal to V times I. So I'm expecting that the power will be equal to 0, right? Because the current at that point is equal to 0. But what about the energy? No, the energy is equal to a specific value because I have a voltage. So I'm expecting there is an energy. And for the capacitor is charging based on keeping some positive negative charges, so I have potential difference. Although there is no current, but I have potential difference, and this potential difference has work or has energy. That's why, although there is no current, but I have energy. Although there is no power, but I have voltage, but I don't have currents. Okay? So if you try to substitute here at the end, you will realize that the voltage should be equal to 0, 10, the current should be equal to 0, the power should be equal to 0, and if you try to calculate the energy, which is half CV square, it should be equal to 10 microjoule. This is in case of you are talking about that time, which is 40 microseconds. And this is what I put here based on these curves. I don't have current, but I have voltage. I don't have power, but I have energy. Okay, guys? Yes. Yeah, this is what I used. Yeah, because I have a specific value. Yeah, half CV square. And this is what I used for calculating it. I said this is half CV square. Actually, V is equal to 10, and C, it was equal to 0.2. So I said the work is equal to half multiplied by 0.2 squared, multiplied by 0.2 multiplied by V squared. So I have half times 0.2 micro multiplied by V, which is 10 squared. It gives me 10 microjoule.
And that point on the previous curve is like a line.
Any other question, guys? Yes.
After the time 40, the capacitor with like the full bottle of water, then we can use.
Any other question for this problem? Let us talk about another problem, which will be the last problem in that part. He asked me to find IC of t if the capacitor voltage is given by the following. So he gave me this guy. This guy is 2. Sorry, this guy is 1. This is 2. This is 3. This is 4. This is 10. And this is negative 10. And he said this is the circuit that he is talking about. And this is IC of t. And this is VC of t. And this is 100 microfarad. And what you have to do, you have to calculate IC of t. So for calculating IC of t, this is the voltage. He said this is VC of t. For calculating IC of t, I have to find the equation for this, the equation for this, the equation for this. Why? Because if you would like to find the current, you have first to define the voltage. But he gave me the voltage as different, different functions or different lines. So I have to find the equation of this guy, the equation of this guy, and the equation of this guy. I'm lucky because we are dealing with a straight line. Do you remember how to find the equation for the straight line? So if you would like to find the equation of the straight line, I can say y minus y2 over x minus x2 is equal to y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Doesn't matter. Now, let me talk about this line. Imagine that you know two different points here. This point, which is 0 and 0, and this is another point, which is, for example, 1 millisecond and 10. And for this guy, this point is 3 millisecond and negative 10. And for this point, I know it is 4 millisecond and 0. So I will show you only one equation, and I'll leave the rest to you because it is straightforward. Let us talk about the first line, which is this guy. What does y represent here? Actually, y is representing v. So I will substitute this guy by v. And what is x? X is the time. What's y2? I will assume that this point, for example, is y1, and this point is representing the point 1, and this point is representing the point 2. So y2, based on that, is representing 10. And what about x2? It is representing 1 milli. And here, this is 10, and this guy is 1 milli, and y1 is 0, and x1 is representing t, which is 0. So based on that, I can find the equation for the first line, and based on that, I can find the equation for the second line, but I have these 2 points. And based on that, I can find the equation for the third line, but I have these 2 points. If you're trying to find the equation for the voltage, you will realize that V of t is equal to 10,000 t, or 0.02 minus 10,000 t, or negative 0.01 plus 10,000 t, or 0. The first one, in case of t, in between 0 and 1 millisecond. And the second equation, in case of t, in between 1 millisecond and 3 millisecond. And the third one, in case of t, in between 3 millisecond and 4 millisecond. And after 4 millisecond, the voltage is equal to 0. What is the next step? The next step is to substitute for finding the current. Actually, I know that the current IC of t is equal to C dV by dt. What is the value of C? The value is 100 microfarad multiplied by dV by dt, which is equal to 10 to the power negative 4 dV by dt. Then the next step is to find the current for different periods. If you try to talk about the first period, 10 to the power negative 4 multiplied by the first derivative of this. The first derivative of this will give me 10,000. 10,000 times 10 to the power negative 4 will be 10,000 times 10 to the power negative 4 will be 1. Yes. So the first one will be 1. Then no need to write those because I can find them to save my time. Then dV by dt for this guy, dV by dt for this will be 0. And dV by dt for this will be negative 10,000 times 10 to the power negative 4. It will be negative 1. Again, the derivative of this will be 0, and this will give me 1. And last one will give me 0. This is in case of t in between 0 and 1 millisecond, and this is in case in between 1 millisecond and 3 millisecond, and this is in case of 3 millisecond and 4 millisecond, and the last one t greater than or equal to 4 millisecond. If you would like to draw that, I didn't ask you to sketch it. If you would like, if this guy is t in millisecond, and we have here 1, we have 2, we have 3, we have 4. So in between, and this guy is IC of t in amps. From 0 to 1, I have 1. From 1 to 2, I have negative 1. From 2 to 3, I have positive 1. Oh, I'm sorry. This is 1 to 3. You are right. Yeah. Between 3 to 4, it is 1. And after that, it is 0. So this is 1 and this is negative 1. This will be your result for the current. Any question for that problem? Yes.
Sir, if in the question for the voltage diagram, we're given the voltage does not end at 0, 0, should we still show that the current is 0 at the end? Because in the last sum that you showed to us,
What do you mean? What do you mean about?
in this diagram,
Yes.
it ends at 4, 0, right?
For which is this one?
Yeah.
Yeah.
So if this point did not end at 0,
Yes.
but ended at some other number,
You have to find I at that number, and you will stop.
okay, so we will not
Yeah.
write that I can get to 0.
Any question for that problem, guys? In the notes, there is one more problem. If you would like to go over it, it is straightforward. I give you the current, and I asked you to find the voltage. So what we have covered so far, we have already covered the inductor, the capacitor, and the resistor. So our next class will be, what about if I have R and L? So we covered R only, if I have only one R, if I have only L, if I have only C. What about if I have R and L in the circuit? What about if I have R and C in the circuit? What about if I have R and C connected in series or connected in parallel? Or R and L connected in series or connected in parallel? What about if I have RLC connected in series or in parallel? This will be our talk for the next weeks. And this is the end for today's class. This is the end of the second midterm. So the second midterm will cover everything from the beginning up to today's class and including it. Okay? So it will cover all assignments 1, 2, 3, and 4. Do we have 5? And 5 as well. I don't remember how many assignments. So the 5 assignments will be included in the midterm. On Monday, if you have any question, I can go over all of your questions. And if you have any question related to assignment number 5, please ask me on Monday during the class. Have a great weekend.